cheapest way to build something is to remove it from the design. The CEO of a massive construction company once said to me, "The money in construction is in the work that you don't do." This is a comment that is stuck with me because I think the mindset we have as construction managers is, and when we think of managing a construction project well, is we think of detailed Gantt charts, perfectly coordinating works on sites, timeless precision, and perfect quality management systems. While those things definitely matter, the low-hanging fruit is to question the original requirements and find smarter ways to do things. The money is in the work we don't do, and that's what value engineering is. So the drawings show we have to dig a trench from A to B. Say it's a communications trench. Can we put those conduits in another trench? Is there another existing route we can take? Can we put in a wireless communication link? Say we do still have to do it. There's then 100 different ways or approaches we could use to dig that same trench. We could have one crew, two crews, or three crews. We could use different sized excavators. We could use a trenching machine. All of these options have different cost, productivities. Some of them have fixed mobilization cost. Some of them have slower productivities, but lower mobilization cost. If you have 2 weeks to price a project and put a proposal together, then it is impossible to explore all of these different options. Now, obviously, the way we do this in practice is we engage with subject matter experts who have intuition and 25 years of experience doing these types of projects. So the process I'm going to talk about today is not a substitute for doing that, but it also doesn't mean that these people's intuition is necessarily correct. They might not have all the data, they might not have all the information, and more often than not, we might or probably won't have access to a subject matter expert with that much experience. You know who's great at exploring tons of options and going through tons of data and simulating tons of different combinations? Artificial intelligence. So in this video, I'm going to explain a system where you can use AI to come up with genuinely useful value engineering options. It presents the options to you and you make the judgment as to whether or not they'll work. So we're going to explore 3 different areas of the project when we talk about value engineering. First one is going to be design. We're going to talk about avoiding scope growth and gold plating by making sure we only actually build what we're contractually obligated to build. We'll then talk about procurement and how we find savings in our procurement strategy. And then we'll talk about methodology and program and asking and simulating, are we coming up with the best way to deliver the project? Importantly, I'll also talk about how to set up a skeptic panel that can grade the outputs depending on cost, safety, program, contracts, everything we care about when we define project success. Okay, so the obvious way to do this would just be to open something like Claude or any of the agent harnesses within your project and ask it, find me savings in my project and return those to me in a report. Now, there's a couple of problems with this approach. And to be fair, it may actually return something useful, but more than likely, it's going to consume a ton of tokens, it's going to take a ton of time, and it's only going to give you these surface level generic responses. So there's really 4 problems that you're going to come across with this approach. Well, number 1 is it doesn't know where to look or what to look for. So you might have open this in a project folder that has drawings, specifications, contract documents, a ton of other information. So it's going to sort of come across this project folder full of information and it's got no idea where to look. It also doesn't know what kind of savings are you after. Is this a design and construct contract where you're actually looking to check if the design's been over-engineered, or are you looking to optimize your procurement strategy, or are you looking to reduce your construction costs? So where specifically do you want to look? It also doesn't know what's previously been explored and understood and why certain design decisions have been made. And then it also doesn't understand where is the money, where are the actual potential savings on the project. On top of this, there's quite a significant technical problem with all these agent harnesses, where the unit of retrieval is the file. So this works with software engineering, where you're trying to process a 20 kilobyte text file, but this doesn't work with construction, where we're dealing with 20, 30 megabyte sets of PDF drawings. Now, I cover this problem in way more detail in our video on AI for construction project managers. So I'm not really going to restate the problem here, but effectively the issue is we overwhelm our context window and we basically, the more information we feed the model, the worse the results we get. Just quickly, if you do want a really easy way to build AI agents for construction, much easier than using things like Claude and ChatGPT, tailored to construction workflows and the type of construction documents that we deal with, then definitely check out Mastt and our agent builder. I'll put a link for it in the video description. So the way we're actually going to run this value engineering process is we're going to have 3 distinct workflows. We're going to have a design workflow, which reviews the documents and drawings we've prepared if it's the design and construct contract, to look for gold plating or scope growth in the design. Effectively, when we're doing something or we've got something in the design that we don't actually have to do, we're going to have a procurement workflow where we look at potential savings in our contracting strategy. And then we're going to have a construction and methodology workflow that looks at our methodology and looks for savings by changing up the methodology. So basically, we're constraining the model's focus to address one of these specific problems. And in the workflow we create, we're going to be very clearly defining what is the inputs to it and what is the context it actually has to use and address. So before you run any of these workflows, the thing you want to have done is set up your construction project folders correctly. And basically the way I do this is I have markdown representations of all my documents in an AI context folder. Markdown is the format that's much easier for AI to read. And then I split up all my construction drawings into individual files. So again, if AI wants to read a drawing, it can look at that single file rather than a 20 megabyte set. Very, very simple thing to do, but it just creates this context folder for AI. Oh, and I also create a CLAUDE.md file, which tells AI, basically gives it an index of my project folder and tells it where everything lives. The next step I do is I get AI to go through my AI context folder. So once I've actually set up my AI context folder, I get it to create what is referred to as a requirements register. So a requirements register is basically everything the client is asking us to do documented in one long workbook. This is going to consist of product requirements, so what we're physically being asked to build, and process requirements, things like training, spare parts, operations, and maintenance. So effectively what we've done in this first step is we've turned our messy construction documents into context that is easy for AI to access, and we have this structured set of requirements. The other 2 things we need to make sure AI has access to for any of these workflows to work is our actual estimate or budget for the project. Value engineering only makes sense if we're saving money. So we need to actually understand the 80-20 of our project budget. If we can give it our estimate with all of our workings, our breakdown of the project scope, so AI can clearly see what different things are costing, it's going to be able to look for the low-hanging fruit with the big items. If we have one line item that is $300,000, that makes sense that we put our time and attention into finding savings there rather than another line item that is $5,000. Because if we can find 10% savings in the $5,000 line item, who cares? Now, that same principle applies to the construction program, but instead of looking at the big cost items, we want to constrain AI's focus to focusing on the critical part, the series of activities that, if delayed, will delay project completion. Now, what I recommend doing is for each of these 3 sets of workflows, the value engineering design, the value engineering procurement, the value engineering on the methodology, I recommend creating a Claude skill that captures your workflow, but you can also do this with a prompt. A skill just helps you actually save that so you can reuse that workflow. So I actually created this value engineering design skill that I'm going to walk you through the contents and structure of. So what happens on a design and construct project is we're asked to take the project specifications and high-level project requirements, maybe even concept design. Typically, we sign a contract saying we're going to take these requirements, we're going to develop a detailed issue for construction drawing set. The problem that happens here is as we go through the detailed design process, we get scope growth. So maybe in the original requirements, there was nothing in there that said we had to termite proof our electrical cables, but all of a sudden in the IFC design, we have termite proof cables that are 20% more expensive. If we then go and buy and install termite proof cables, we have wasted 20% of our cabling budget for a requirement that we never actually had to meet. This is known as scope creep or gold plating. And the check we want AI to help us do is what we are currently designing and agreeing to do. Does it meet the original requirements or does it exceed them? Now, the core challenge with this entire workflow is going to be how well AI can read and understand construction drawings. And there's been a ton of stuff out there about how AI struggles with visual reasoning interpretation. So as much as possible, we're going to try and get it to look for savings in the product specified. Because at the end of the day, we're not going to be able to get AI to work out, is our pile oversized depending on the original design requirements? Because that is a complicated civil engineering workflow. We have to be a bit realistic with what we're trying to achieve. We're going to look for things like, is the light fitting specified above the electrical spec calls up? We're not asking AI to redo all the lux calculations to work out if our lux calculations are wrong. We're being very focused on more about the actual products and materials being used. So some examples of this might be using a different type of paint, like a high build epoxy system on a finishes schedule, when we could have just got away with a standard acrylic paint. Maybe a higher strength concrete than we actually needed. Light fittings that have a higher IP rating than what the documents actually specified. Maybe we've got hot dip galvanized steel when we could have just got away with painted steel, or whether we're using copper pipework when we could have used plastic pipework. Okay, so we specify in the skill what it can and cannot realistically check. So we're constraining it to very much focus on what it can actually quite easily verify. We then give it as input the source client documents, our documents, so our issue for construction drawing set, our schedule, our specifications, and the estimate or budget we had for the project. Then, if we haven't done this already, we first need to go through and extract all the requirements from documents. We should then categorize these requirements. What actually came from the original requirements? What requirements have been developed in our documentation? What requirements have been implied by a clause or a code? Because obviously we don't want to push back on things that, for example, if you install like a pool, like it has to have a pool fence, like those would be implied requirements. And typically those are more to do with like safety or industry standards. Well, actually the pool fence was a bad example because there's obviously going to be a standard somewhere that says you have to have a pool fence, but implied would just mean like standard or acceptable practice that typically wouldn't be in a specification. So we want to be careful about not pushing back on things like those because that obviously doesn't make sense to. Then we go and extract our documented design and we do a systematic comparison and grade each of the requirements that has come out in our design. So our drawing, the specifications, what we're actually saying we're going to build. We go through all the product that we're actually creating and we say, is this compliant? Does it match the requirement? Is it over-specified? Is it not required? Is it under-specified or it cannot assess? Then we go through as a separate pass and then we actually score these. So we use the original, we tell AI to use the original estimate and grade which of these over-compliant ones to look for the over-specified issues, have a big cost to them, and then we put some estimate of the saving together. And then we get AI to output this into some simple register, which determines where the requirements come from, what the potential savings are if we have over-specified. So again, this systematic comparison of what we are saying we're going to build in the issue for construction design, the specifications, the schedules we've developed, versus the original requirements in the client's contract documents, and are we over-specifying what we need to do, and where are the potential savings in diverting to the client's original standards. So where this workflow will struggle to run is where you don't have clearly documented contract standards or whether something is versus what is a developed requirement. So if you don't have a clear list of what the contract was signed on, the concept design, specification A, specification B, specification C, you effectively can't run this. So a lot of this actually comes back to head contract management. And then we're very limited by how well AI can understand the actual construction drawings. And obviously, it can infer why the design is a certain way. Again, I gave the example of the calculations that would go into sizing a pile or determining how many light fittings you have to determine what the lux levels are. It's not going to work. It's not going to be able to reverse engineer how those things came up with. Maybe when we get super intelligence, it will eventually, and we get things like world models that can actually do physical real world calculations, but realistically now it's not going to be able to do that. Okay, so that is the focus on the design and the development of the project requirements. What about the procurement phase? So what we're really looking for in the procurement stage is we've come up with our list of packages to issue to the market. We've said we're going to have an electrical package, we're going to have a mechanical package, we're going to have a civil package. Can we break up and reshape these packages to look for potential savings? For example, say the electrical package is $2 million, but within there, the electrical contractor is spending $200,000 on a main switchboard and $300,000 on a generator. Those are big, bulky items where we could potentially go to the supplier, buy them direct, and cut out subcontractor's margin on it. So what procurement value engineering strategy is going to look up? How can we reshape our package register to find potential savings? So the key input to this is going to be our list of subcontractors and suppliers. We also need to know a summary of what is in each package, and we also want to know the budget for that package, and ideally a breakdown of how that budget has been calculated from our original estimate. What this workflow is then going to do is basically look at the budget for each package, the scope, and again, if it has access to the estimate and any first principles pricing you have, or even the breakdown of the subcontractor scope, what are the big bulky items in there that would be easy for us to break out of that package and free issue? So for example, you might have a combined civil and concrete package, but the concrete scope would actually not be that hard to manage ourselves. It takes place in a different time in the schedule. We know our earthwork subcontractor is probably subcontracting that to another subcontractor. So potentially we could split up the package. So what this is going to do is going to go through your procurement register and assess, should we be breaking up these packages more? Now, the example I give of when you shouldn't be doing this is you have to understand with every additional package you add to your procurement register, that's another package you have to manage. That's another contract you have to let. That's another supplier you have to organize delivery. So for that electrical subcontract package, it wouldn't make sense to free issue all the cable ties to the subcontractor. We might save $50 on $500 of cable trays, but then run out. We might misorder how many cable ties we need, and then the electrical contractor is standing around for 2 days waiting for materials to get delivered, and we get hit with a $6,000 delay to save $50. There's obviously a very fine line between how we do this. So really within the skill, we want to be very clear, and I actually have put this in the skill as the cable die test. It should have a small number of large units, should be easy to free issue. They should have significant margin on it. It should potentially be a long lead time item, so we could split it out. We could get savings on the schedule. And then we want to look at what the easiest way to us to actually free issue for it is. Another much simpler way you could do this is you could actually go out to quotes from your subcontractors and get them to break down their quotes and also look at options to free issue. Now, you don't even need AI to do this. You could just go get a quote for the generator versus in your subcontractor's schedule what their price for the generator is and explore these options yourself. But again, AI would come into value here because we would have a lot of different quotes and it would be tough for us to go through and do all of this properly. So again, if you actually have some contractor quotes for this, just getting options from your subcontractor is probably a more effective way to do this. Okay, so that is the procurement workflow. The final one I want to talk through is the methodology workflow. Now, the methodology workflow is where we look at the plants, the crews, the sequence, the production rates. We look at all the different data sources and we basically simulate different options to save money. So if I use the example of digging a trench, should we have one crew and then we'll take longer to do the work, which might increase our indirect costs because the project, if the trenching is on the critical path, it increases our indirect costs, which means we have to pay more project management and supervision. We could have two crews, but then we'd be paying for an additional mobilization. Maybe we wouldn't get the same productivity because we're doing a shortened period of work, and then we pay a fixed cost to bring the subcontractors and supply to site to do their mobilization. So this input, it's very important to have a detailed construction estimate, a construction program, which is your baseline methodology, any production rates or input information for different things, which I guess would come from your business's cost library or anything like that. And you also want to know your indirect and preliminary costs per week, because one of the key trade-offs that I think projects can save a lot of money on is the trade-off between doing work faster and increasing your indirect cost versus, doing work faster and decreasing your indirect costs, but increasing your direct costs because you're not going to get the same productivities than if you have smaller crews working slowly, versus do you try to do the work slower, but then you'll pay more in your preliminaries because your preliminaries you pay per week. So effectively what this skill is going to look at, it's going to look at the low hanging fruits in our construction estimate. It's going to look for the big dollar figures, and then it's going to try and come up with different options using different plant. Again, this will work much better if you actually have all the rates. It's going to look at the fixed cost per task and basically come up with its suggested best methodology. Now, this one becomes really, really important that you have a lot of data you feed into it, because there's so many different variables. And if we don't actually have the actual rates and information, we're not going to get good results. So we want the crew numbers, the plant size, the productivity rates for different crews with different numbers, what the cost of, say, building and prefabricating something off-site is versus doing it in situ, basically all these different tasks. And then once we have all the actual data, the workflow itself is very simple. We feed it the estimate, the program, production rates. It looks at the big ticket items also and compares this to savings in the schedule and just comes up with what the net impact of different options are and creates our value engineering register. We can basically assess what is the best option for our project. Now, the final thing I like to do is, because any value engineering takes the perspective of cost, and there's something there's actually a lot of research into getting the best results of AI has been saying, is that when you give AI a defined task, it has to really do two things. It has to do the task and then check whether it's done the task correctly. The analogy I heard is like you ask an employee to fill out their own performance evaluation and then get them to grade it depending on whether or not they should get a raise. Basically, the models judge the quality of the output they've produced much higher than if you were to send this output to another model and get it to independently check it. So the last part of this process is, before you actually go and review all of these options, you want to create what I refer to as a skeptic panel. So you run your value engineering options, then you get AI to actually independently, from the perspective of different people on a construction project, assess whether these are genuinely good options or whether AI is over-indexing for cost savings. So I like to have and it does this by deploying independent subagents. So an independent subagent is a specific instance of Claude with a fresh context window that will retrieve the information from the main chat, but with a very targeted perspective. So we have the commercial manager, we have the constructor, we have the supervisor, and then all of them respond based on what their assessment of the options is. So we're also getting perspectives about safety, whether there's specific issues that will come up with the methodology, whether it actually works in practice in site by having the supervisor. But then we're also getting the commercial manager who's got to focus on things like commercial risk. Basically, we're introducing multiple perspectives into our workflow so we get the best possible results and we get genuinely useful value engineering options. Now, one thing you want to be careful when you're actually writing the prompts to do this is you don't want it to be critical. Something you find is if you tell a model to be critical, it will start to invent problems. So that's why specifically in the prompt, the instruction to each subagent is to make the case against this candidate. It's making a strong argument against it. It's not being critical for the sake of being critical. And basically you get feedback that you're not just looking at cost perspective, but you get time, safety, and constructability. So the entire purpose of this workflow is it isn't deciding anything or making changes. All it is doing is presenting you the best possible options based on the information you have. You then have the power to make judgments of whether this makes sense or where it doesn't make sense. Now, if you are interested in learning more about these different AI techniques, understanding better what context is, what context rod is, and why we do things in a specific process, then check out this video next, where we have a complete guide to AI for construction managers.